बहुत ही interest. So today we will discuss a very interesting topic, and the name of this topic is rotational dynamics. Let me introduce rotational dynamics. Rotational dynamics. Dynamics. The chapter is a very interesting. We will see that how much interesting about this chapter. So when we talk about the rotational dynamic, the chapter says about their self itself that the first topic comes in this rotational dynamics is the moment of inertia. Moment of inertia. Moment of inertia. So first of all, I want to tell you about the what is the meaning of moment of inertia and in which factor it's depend on. So it is a property. What is this moment of inertia? It is a property of opposes to change in a angular motion and the mathematical formula for this will be I. The I is the denotation of moment of inertia, and this I is I equal to m. M is the mass of this particle, and perpendicular distance from axis of rotation. This is the mathematical representation of a moment of inertia. So when we represent I equal to m into r perpendicular, basically what does this formula want to say? What does this formula want to say? Just I am explaining. So suppose this is a axis of rotation. Okay, I want to rotate a mass about this axis, and the distance of mass from this axis is r. So how to define the moment of inertia of this axis about this mass? So this I will be I. You have written I, and this mass and this perpendicular distance is r perpendicular ka square. This is the moment of inertia about this axis. Now again let us proceed to that part. Okay, so this is a moment of inertia. So moment of inertia depends on some factors. I will discuss about each of this factor. The moment of inertia depend on mass distribution and axis of rotation and perpendicular distance from the axis of rotation. Let me take another page, and that is no. So let us discuss about the dependency of moment of inertia. Dependency of moment of inertia. So the first will be it is mass, and the second will be mass distribution, and the third one is axis of rotation, and the fourth one will be the perpendicular distance of rotation, and fourth one is a size of shape, how the shape is. Now we will define each term, how moment of inertia is depend on mass, how mass distribution, axis of rotation, and perpendicular distance of rotation and size inches. Suppose this is a axis of rotation. Okay guys, now this is our axis of rotation. The first mass will be here at distance r1, and the same mass, at the same distance, I have placed a 2m mass. So the moment of inertia, if you want to define the moment of inertia of this mass about this axis, you will write I equal to m into r perpendicular square. And if you want to write the moment of inertia of this mass, it will be 2m into r perpendicular square. And so this is, suppose this is I1 and this is I2. In this case we can say I2 is greater than I1. So the first situation, that is depend on the mass, it is clear that it is already depend on the mass. Now the next one is a perpendicular distance of axis of rotation. Suppose let us consider a same mass. This is m and this is also m, but this is at a r distance, this is at a 2r distance, and the moment of inertia of this, again this is considered I1 and this is I2. So in this case you will define m into r square, and in this case m into 2r square. So this is 4mr square, which is I2 is greater than I1, and so this is also verified that moment of inertia is depend on the perpendicular axis of perpendicular distance from a axis of rotation. Let us come to the next one, that perpendicular moment of inertia is depend on the mass distribution. As we know that the more will be the mass, moment of inertia will be the more, because as the formula says I equal to mr square, the formula says that if more will be the mass, more will be the moment of inertia. And if there is a more the mass distribution, the moment of inertia will be more. So suppose there is a situation, there is a block, this is like, this is m. As we go from lower end to upper end, their masses distributions is increases, and this is we want to find out the moment of inertia of about two axes. This is I1 and this is I2. So guys, if you want to find the moment of inertia about this axis, this I1, so the more number of masses means heavier masses will be farther from this I1. So I1 will be the greater than to I2, and in this case the more masses will be very nearer to I2. So the moment of inertia of I2 will be less than I1. So I think it is clear about everything. Now the last one more example is that moment of inertia is depend on mass distribution. How it depend on, we have discussed about. So I think it is clear about what is moment of inertia. So moment of inertia is a property in a rigid dynamics. Just like that, in a linear motion, what we say that in a linear motion there is a inertia. So same things comes in a rigid mechanics, that it is a moment of inertia. So the moment of inertia is a tensor quantity. Moment of inertia is a tensor quantity. Let me write it. Moment of inertia is a tensor quantity. Moment of inertia is a tensor quantity. So if it is a tensor quantity, that's why if two or more masses rotated with a common axis, with respect to a common axis, then in this case the total moment inertia will be the addition of the both. Moment of inertia is a tensor quantity. That's why if two or more masses, this is a note point, if two or more masses rotated about a common point, common point. In this case, the net moment of inertia will be addition of both. Let's take an example. Suppose this is the axis and we want to find out the moment of inertia about this axis. This is a m1 mass and this is m2 mass and this is m3 mass. This is at r1 distance, r2 distance and r3 distance. So in this case the I net will be I1 plus I2 plus I3. I1 plus I2 plus I3. What is I1? Again this is mass m1 into perpendicular square r1 square, फिर mass into r2 square, mass into r3 square. So in a summarization we can write this is summation of mi ri ka square. This is I1 say 3. This is the I net. I hope you are able to write about the moment of inertia. So this is a perpendicular. Whenever we take a r, this r is nothing else. This is a perpendicular distance. So now we want to take some questions on moment of inertia. As the basics of moment of inertia is clear, now we should move to the question. Let us take some question. Okay guys, so the question will be now. The first question, the first basic question will be okay, this is good. Okay, we want to find the moment of inertia about this axis. Okay, the first mass at a distance m1 and the second mass at a distance m2, at a distance r1. This is r2. So if we want to find the moment of inertia, just what you have to do in the both cases, what will be right? I equal to m1 and the distance. This is a perpendicular distance. Don't take this distance, don't take this distance. The perpendicular distance from this axis will be the r perpendicular, r1 square, and this is m2 into r perpendicular. So this is all about the moment of inertia. So if I am telling about the what is the unit of moment of inertia, that is, if I am writing m into r square, so this will be the kg into meter square. This is a unit of moment of inertia. Now let's take another question, that suppose this is a ring and we want to find the moment of inertia about this axis. Okay, so so we will take this question another after some time. So let us take some another question, and the question will be very interesting, that the m1 mass is here and m2 mass is here, and we want to find the moment of inertia about this axis. Okay, so this is m1. If we want to find the moment of inertia, this is r. I and I net will be m1 into r perpendicular plus m2 into r perpendicular. If you see that the distance of m1 from I1 is 0, means there is no distance, because mass m1 is itself on this I1 axis. So m1 into 0 plus m2 into r square, and this I will be m2 into r square. So if a mass lie on the same axis where we have to find the moment of inertia, then the moment of inertia will do not create about the same mass in the same situation. Just I have given an example. Let's take another question. that this is a mass m1 and another mass m2 at a distance L, and we have to find the moment of inertia about this axis. So in this case, it is given that the angle is theta. So again, there is a no moment of inertia about this mass m1 because m1 is lie on that axis where we have to find the moment of inertia. So if we write mi equal to, this is m1 into 0 plus m2 into perpendicular distance. This is a perpendicular distance of m2 from the this axis, and this is L sine theta. So we have to write L sine theta ka square, and now this I will be m2 into L sine theta sine square theta. Sorry, ml square m2 L square sine square theta. So this is all about our moment of inertia in a simple term. Let's proceed to the next part. Let's take a question. Suppose, as I can assume that you all of you have study about the center of mass. So let's take a one more very familiar question, that there are two masses. This is m1 and this is m2. Okay, and we have to find the moment of inertia about this axis. Okay, this is the mass, this is the, and we have to find the moment of inertia about the center of mass, about its center of mass. The question is, there is 2 point masses m1 and m2 placed at a distance L at a part. Find out the moment of inertia of the system about an axis passing through its center of mass at perpendicular to the line joining of the particle. Basically, in a short way, you can say that you have to find the moment of inertia about a point which passing through the center of mass. So in this case, if the distance between these two masses is L, we can write m. We know that the center of mass, the distance of center of mass from this mass will be m2 into L plus m1 plus m2. I have write this result from the center of mass, and now distance of center of mass from this mass will be m1 into L upon m1 plus m2. Now we need to find the moment of inertia about that axis which is passing through the center of mass. So I net will be I1 plus I2, and this I1 will be m1 into this distance, and this distance is what, m2L upon m1 plus m2, m1 plus m2. This is m2L upon m1 plus m2 ka square plus m2 into this m1 into L upon m1 plus m2 ka square. And after this, after solving all these things, what we will got m1 m2 square L square upon m1 plus m2 plus m2 m1 square L square upon m1 plus m2. If we want to solve this, I will got I equal to m1 m2 upon m1 plus m2 into L square, and you are familiar that we reduce mass. This is known as a reduced mass. We say that this is a reduced mass. We named this function, the term, the quantity which comes from these things, we have named that this is a reduced mass, and I equal to, I am writing that u into L square, and this nu barabar m1 into m2 upon m1 plus m2. Now let us take one more question. Now this is a triangle, mass m, this is also m, and this is also m. Okay, so we have to find the moment of inertia about this mass, about this axis. and this is a equilateral triangle, and the length of this triangle will be an equilateral triangle. So this is again the same situation. What is the distance of this mass? The moment of inertia about this mass, or about this, the moment of inertia of this axis about this mass will be 0, because the mass lie on this axis. And from this, the distance of this mass is L. The distance of this mass will be L by 2. This is L by 2. L by 2. So what will be right? The moment of inertia I will be I1 plus I2 plus I3. This is I1, this is I2, and this is I3. This is I3. So the I1 will be m into 0, and I2 will be m into L square. I3 will be m into L by 2 ka square. Now I will be ml square plus ml square by 4. Now after solving this, we will got 5 ml square by 4. This is our answer.